Okay, so matrix operations, scalar multiplication, really simple stuff, I think. In matrix algebra, a real number is often called a scalar. To multiply a matrix by a scalar, you multiply each entry in the matrix by the scalar. This process is called scalar multiplication. So that was my without commercial interruption thing. So this is what we're going to do here. It is simply distribution. We're going to do 3 times that number, then 3 times that number, and then, if you don't mind, 3 times this number. So all the entries are going to be multiplied, right? And let's take a look at what that would look like. I could write this whole thing out, but let's just follow this as a diagram. I think that it's relatively simple, isn't it? 3 times negative 2 is negative 6, I believe. It doesn't matter what order you do this in, what does matter is that you put in the correct position. So I'm doing now second row, first column, right? So I'm down here, so 3 times 4 is 12, so that 12 has to go here. 3 times 0, even though the answer is 0, you have to write the 0 in to hold that place, please. And then 3 times 7 is 21, so that's pretty easy scalar multiplication, isn't it? All right, the second example is just what we have here is an example of scalar multiplication and then addition. So let me ask you this question. If you were going to do multiplication or addition first, given the order of operations, which one would you do first? And of course the answer is that you do multiplication before addition. So that's all we're going to do here, is we're going to multiply our scalar through here, and it's just times this one. If it was times the whole thing, it'd have to be quantified differently, or possibly this negative 2 would be moved here. So let's take a look at this. So all we're going to do the same thing that we described before. We're going to multiply this times this, and then possibly times this, and then this times this, and then times this, and then this times this, and then this times this. And we're going to come up with a new matrix, I think, aren't we? So our new matrix would look like this. Negative 2 times 1 is negative 2. Negative 2 times negative 2 is positive 4, isn't it? Negative 2 times 0 is 0. Negative 2 times positive 3 is negative 6. Negative 2 times negative 4 is 8. Negative 2 times positive 5 is negative 10. Isn't that right? Now, if I was more brilliant, I was more tech savvy, I could move this damn thing down, but I can't, and when I try, it just goes completely on me, so I apologize. So I'm just going to rewrite the second matrix because I haven't done that operation yet, right? We have 8, 6, right? And now it says to add. And remember, when we add like destinations. So I'm suggesting to you that these are the same places. I'm not going to do all of them this way, but just to show it to you, I'm going to add this one to this one. First thing I checked, though, was to make sure that the matrices are the same size, and they are. They're all 3 by 2 matrices, right? Rows by columns. So I'm going to add this to this. I'm going to get negative 2 plus negative 4 is negative 6, isn't it? And then I'm going to multiply these places. I'm going to add these places together, this place and this place, right? And 4 plus 5 is 9. And I'm just going to just continue that process. You don't need to hear me talk through it, but this one and this one are in the same position, aren't they? And 0 plus 6 is 6, I believe, is 6. I do the same thing here. Negative 6 plus negative 8 is negative 14. I could write a 14. Negative 14. 8 plus negative 2 is 6, isn't it? And 8 plus 6 is 14. So if I add these two matrices together, if I multiply this matrix times this and then add the two resulting matrices together, this is my solution. So the answer is this matrix. This is my solution. What I do wrong? Oh my God, didn't nobody... so you guys are like, God, the guy's an idiot. Okay, he is. Negative 10, right? Negative 10 plus 6 is negative 4, isn't it? Sorry, I was just checking my math. Hopefully you were checking yours too, right? So negative 6, 6, 6, 9, negative 14, negative 4 is our resulting matrix. So we did scalar multiplication and then addition on top of that. So hopefully your matrix skills are getting better. So keep up the good work.